Hi there. As you know, there are three main methods for estimating the fatigue life, namely the stress life method, the strain life method, and the linear elastic fracture mechanics method. So today we are going to explain the first method, which is stress life method. Before I get into the SS life method, I have to say that in fatigue, there is a classification according to the number of cycles. Typically, life till 1000 cycles is categorized in low cycle fatigue, while the cycles of more than 1000 are considered as high cycle fatigue. Okay, let's define the stress life method. The stress life method is trying to correlate the fatigue life with respect to the cyclic stress that has been applied on the structure. And this correlation is plotted in a curve which is the so-called SN curve. Okay, how this curve should look like? I mean, the slope of this curve should be positive like this or negative like this. If you reduce the amplitude of the applied cyclic load, you will have more cycles before failure. Something quite logical, right? It means the applied cyclic load and number of cycles before failure are inversely, right? Inversely correlated. Therefore, the slope of the curve should be negative, something like this. Okay, now how do they plot the curve? First, I have to say that each material has its own SN curve. SN curve for stainless steel, like for mild steel, for aluminum, and so on. So during the test, the specimen is subjected to a cyclic load. It means the curve of force over time is something like this. The amplitude of this curve is the value of applied stress. So theoretically, if we get started with the ultimate stress of that material, it will fail immediately. It means, so the identical point of the ultimate strength is 10 power 0, which equals 1. It means if a material is loaded with a cyclic load of ultimate strength of that material, it will fail at the first cycle. So the failure on the first cycle is the same as static failure. Then they gradually reduce the amplitude of the cyclic load. And for each value of cyclic load, they get a number of cycles till failure. Did you get the idea? So, for sure, by reducing the value of applied cyclic stress, the number of cycles before failure increases, Okay, it's gonna be something like this. Each point that I put here like this presents a test with a specific value of cyclic stress and its result, which is fatigue life. So as I told, till 1000 cycles or 10 power 3 is called low cycle fatigue, and then they go on with these tests points like this. So till 10 power 7 typically called high cycle fatigue. So ferrous materials like steel, somewhere they normally reach a value of the cyclic load which does not lead to failure even after millions of the cycles. So this part could be kind of a straight line showing that the life of the structure under this cyclic load is infinite or very high, So this is a typical SN curve. However, Depending on the material which is tested, as I told, the shape of this curve can be different. For non-ferrous materials like aluminum, there is no horizontal part of curve. I'll explain this more later. So, okay, great. Let's define the important points or the areas of this curve. So this point shows the ultimate strength of the material. Okay, then this area, which is normally till 10 power 3, considered as the low cycle fatigue or LCF area. Then this area, which is typically between 10 power 3 and 10 power 7, is called high cycle fatigue or HCF area. Some references include this part also as the HCF or high cycle fatigue area. However, some other references separate this part and they call it VHCF or UHCF or ultra high cycle fatigue, because this area either have infinite fatigue life or a very high fatigue life. Then this point, which is denoted normally with SE, is called the endurance limit or fatigue limit. This point shows a threshold stress value which results in infinite life or very high life. Then the area under this line is called the infinite life area. It means if you apply a load in this range, or this area, I mean in this green area, you would have an infinite fatigue life, which means theoretically the structure will never fail regardless of how high the number of cycles is. On the contrary to this green area, this area. Alright, this was a short lecture about the stress life method of fatigue life prediction, and then for coming lectures, stay tuned, motivated, and with me as well.